according to the United Nations, 60% of the global greenhouse gas emissions are derived directly from the way that we currently produce our electricity. Wave energy can really be a game changer in that regard. Hello, I'm Ina Braverman, founder and CEO of EcoWave Power. The need for wave energy is undeniable because 2/3 of the world population are currently living on the coastline. We can give clean electricity to people right in proximity to their homes instead of driving electricity from some city or country center to the locations on the coastline. We basically attach floaters to existing man-made structures such as piers, breakwaters, jetties, and other types of marine structures. The floaters are going up and down with the movement of the waves. They're pushing hydraulic cylinders, which transmit biodegradable fluid into land-located accumulators. A pressure is being built, which is used to turn the hydromotor, turning the generator, and via the generator, we send the clean electricity into the grid. The density of water is actually 832 times greater than the density of air, meaning wave energy can produce much larger electricity amounts with much smaller spaces, smaller devices, which is a big advantage. 99% of the developers in the wave energy industry have decided to pursue offshore technologies. And this created 5 problems which were common to all developers. So the first one was the price of their systems, because when you're putting a power station in the middle of the ocean, you need ships and divers and underwater mooring and cables. So the installation, the operation, the maintenance becomes sky high in terms of the cost. Environmentalists, which were supposed to be the greatest proponents and supporters of offshore wave energy, were actually objecting it because it created a new presence on the seabed, which disturbed the marine environment and changed the ecological balance, since the only thing in the water are the floaters, which belong in the water, and all the expensive equipment, the generators, the conversion mechanism, and so on, is located on land, just like a regular power station. So that enables us a cost-efficient and reliable design. Another problem was the survivability and reliability of those systems. So basically, when you're that far into the offshore, you're exposed to wave heights of 20 meters or sometimes even higher. And unfortunately, no man-made stationary equipment can avoid waves of 20 meters and up. Insurance companies saw that it's so expensive and breaking down. They were really reluctant to insure offshore wave energy technologies. Because we're connected to breakwaters, we have a patented storm protection mechanism that when the waves are too high for the system to handle, the floaters actually automatically go up above the water level, and only when the storm passes, the floaters go back into the water and commence operation. Because we're cost efficient and reliable, we also have full insurance from global reputable insurance companies. And then on top of all of these problems, there became a big question mark on whether wave energy can even safely connect to the electrical grid. Because, not many companies, if at all, have connected back then. We have been connected to the grid in Gibraltar for 6 years. Now we've just connected our second power station to the grid in Israel, which became the first wave energy power station in the history of Israel to ever connect to the national electrical grid. We're very, very excited about it.